How many people do we need to create a new civilization? And not on Earth, but on Mars, and in limited conditions. And if we create this colony and send them off, what problems will they face? How can they survive that far away from home without any support? A recent scientific study sheds light on these questions, so let's take a look at it. Alright, so you want to colonize Mars, right? Well, it's not an easy task. Mars is the 4th most distant planet from the Sun and the 7th largest in the solar system. This lonely red guy is very similar to our Earth. Moreover, before it became a boundless desert, it could well have even looked like Earth now. Millions of years ago, there was water, oceans, plants, and who knows, maybe even life. It would be nice to put all these cool things back there. No wonder we've been talking about colonization of this planet for a very long time. Now, SpaceX claims that their proposed interplanetary spacecraft could deliver 100 people to Mars. The owner of the company, billionaire Elon Musk, talked about creating a fleet that could provide a constant flow of resources to Mars. But how realistic are all these fantasies? Actually, not very much. Before sending people to Mars, we need to solve a number of issues. For example, the incredible radiation exposure, toxic soil, low gravity, low temperatures, and all sorts of other nasty things. And this is just the beginning. It will take at least a couple of decades to create a vehicle that can actually successfully land on Mars and return back. But let's do a thought experiment and imagine that we finally decided to colonize Mars. How will things turn out? Recently, scientists published a new study on this topic. This study is called Minimum Number of Settlers for Survival on Another Planet. The author is Jean-Marc Salati, professor at the National Polytechnic Institute of Bordeaux in France. His article was published in the Scientific Reports journal. As you might have guessed, the study was trying to find out how we could colonize another planet. How many resources do we need? How should this colony live? What kind of work should they do? And how long will it take? And, of course, exactly how many people do we need for all of this? Let's try to answer that. Now, imagine that we've moved into a wonderful future. Well, not really. A terrible future, actually. In his study, Salati suggested that life on Earth was threatened by some catastrophic event, so the only way for humanity to survive is to go to Mars or some other planet. In this imaginary scenario, unfortunately, the supply delivery from Earth was interrupted, or even gone. Now, the colony has to support itself somehow. Well, here's where we already stumble upon a bunch of problems. For example, we're not sure how well the people in the colony will work together.
Hey!
Will they communicate with each other like normal human beings? Will they share their time and resources as they should? Humans are constantly ruining things for other humans. I can even bet that it was their fault we had to flee to Mars. But even if we forget about that, how about organizational issues? What equipment do we have? What will we use to extract resources? What skills would we need? You know what? Who cares? In our case, these things don't matter. All that we know is that the colony doesn't have a lot of initial resources and equipment, and the human factor is absolutely unpredictable. So the chances of survival are pretty low, but we need to survive somehow. In this case, Salati describes 2 things that will have a huge impact on our survival. These things are essentially variables in a mathematical equation. The first one is the availability of local resources. Basically, it means water, oxygen, and all sorts of useful chemical elements. These resources should be somehow mined and easy to use. Fortunately, we're not starting from scratch. We already know a lot about Mars. What resources are there? How can they be used for life support, agriculture, and industrial production? The colony is lucky because all this has been studied at various seminars and published in reports and books over the past years. Thanks to this, we know what will be available to our colony. For example, we know that gases could be extracted from the atmosphere and minerals from the soil. On Mars, we could provide such things as iron, glass, and even organic compounds. The most important problem here is the service life of the equipment that our new Martians start with. They'll have to get as many materials as possible before the tools break. Keeping them in good condition will be almost the most important task. The second thing is the production capacity, or the speed of work. We have a specific list of things we need to do, make some tools for example, and all this must be produced in sufficient quantities before the literal deadlines. Salati says that the most important thing here will be the so-called sharing factor. Imagine one person trying to survive on Mars. They would have to do all the tasks on their own. They would need to find or build their own system for supplying drinking water, oxygen, and electricity generation. We've already seen how this played out in the movie The Martian. This task wasn't easy at all. There's always not enough time, and all of this is just too much for one person to handle. Unless you're Matt Damon, of course. So, surprisingly, we need a fairly large colony. This significantly distributes the burden. Each person spends less effort, gets tired less, and, as a result, the efficiency and speed of work grow. This is where the sharing factor comes into play. Now we need to calculate this number. If we want, for example, to build something, how many people do we need to do this quickly and efficiently? How can we optimize the work as much as possible? Well, it depends on the needs of these people, on available resources, random things like weather, and so on. But in general, this number can be estimated and calculated using some mathematical functions. Salati tells in more detail about these functions in his article. You can read it yourself if you're interested, but in general, he describes 5 areas that need to be taken into account when calculating this number. These areas are ecosystem management, energy production, industry, buildings, and the human factor. The human factor includes such things as the upbringing and education of children, sports, games, music, and so on. In the end, it all comes down to 2 things: how much time we have and how well the people in the colony will work with each other. So, what was the result of all these calculations? In the end, Salati found out that we would need at least 110 people to successfully survive on Mars. This is the minimal number needed to create a self-sufficient civilization. And it will be better if we don't take too many people with us. The more people we take on the spacecraft, the more difficult it will be to predict the results. After all, as we've already said, humans are always ruining things for other humans. So it's better to stick with about 110 people. Of course, this is a rough estimate, and there are a bunch of different assumptions and uncertainties, but even this number is already very useful. Now the scientists know how many people is a minimum for colonization of another planet. Colonizing other planets is a very complex issue, and it will take us a very long time to resolve it. It's very unlikely that we'll fly to Mars in the near future. This task may take several decades, or even a century. Therefore, the best solution would be to try our best to save Earth until we can begin to conquer other planets.
Hundreds of spaceships take off from Earth's surface and head toward Mars. Fast forward 7 months, and this space fleet of ships is near the Red Planet. Soon they will all land, and a few thousand people will become citizens of Mars. Perhaps they will never return to their home planet, because there will be absolutely all conditions for a comfortable life here. It takes time and many expeditions to create a self-sustaining colony on Mars. Here is how, step by step, people might build a full-fledged city there, with factories, hospitals, apartment buildings, and even clubs and restaurants. First, we need to pick a time to launch the rocket. A launch window opens once every 780 days. That's when the distance between Earth and Mars is the shortest. In this case, the journey will take about 6 to 7 months. Let's move to the launch pad. Here, we see the spacecraft connected to a booster rocket. Ignition! The booster sends the spacecraft into the air. It then undocks and lands back on Earth. At the same time, the spacecraft's engines start and it makes its way to Earth's parking orbit. To make this ascent, the ship has used almost all its fuel and now needs refueling. To do this, we use our booster again. A huge crane places another spacecraft on the booster. There are huge fuel tanks inside the ship. The booster launches from Earth and takes the refueler into orbit. It docks with the spaceship and fills it with fuel. The journey through space may need a total of 5 such refuelings. And for the first mission to build a colony on Mars, we need 5 spaceships. So that's about 25 launches from Earth. Considering that the booster costs $230 million, the refueler $130 million, and the ship itself is $200 million, the price tag on the mission is pretty impressive. So, ignition. Fast forward in time, and the first 5 ships descend to the surface of Mars. These ships haven't brought the first humans. They carry only payloads, like fuel and water supplies, oxygen for breathing, and medical supplies. There are also first living modules, waste management systems, and a huge number of solar panels for generating electricity. Before landing, one of the ships launches a system of satellites into orbit. It'll provide communication on the red planet. So, the robots begin their work on Mars. First, a whole bunch of little rovers line up and unfold solar panels. Their total area reaches the size of 7 soccer fields. They're much less efficient on Mars than on Earth. Frequent sandstorms fill the working surface of the panels with sand. But at the same time, the strong winds of the red planet also help to wipe the sand away. Other rovers, equipped with powerful drills, begin searching for water in the Martian soil. When they find water, people will begin producing fuel. We'll combine carbon dioxide from the atmosphere with the mined water at a high temperature and under high pressure. It'll result in getting methane for rockets and oxygen for breathing. Since February 2021, Mars Perseverance rover has been testing the technology for oxygen extraction. It has a box inside. This is the Mars Oxygen IRSU experiment, also called MOXIE. This thing pulls Martian air inside and then, under high pressure, takes 1 atom of oxygen from carbon dioxide. Such a thing, about the size of a shoebox, can provide enough oxygen for 1 astronaut to breathe. But if you build the same mechanism, but the size of a large factory, it'll produce oxygen for an entire colony and release the rest into the atmosphere of Mars. Another group of rovers is working to turn the surface of Mars into a landing zone to prepare for the next step in colonizing the red planet. By this time, the robotic population of Mars has been working on these tasks for 2 years and 2 months, and people on Earth have been waiting for a new flight window to open. This time, not 5, but 12 spaceships are coming to Mars. 10 of them are cargo ships, which bring construction materials, fuel, and other supplies, as well as a lot of scientific equipment and 3D printers. 2 other ships carry the first interplanetary astronauts. The doors of the spaceships open, and 30 heroes set foot on the surface of Mars for the first time in history. These people are scientists, engineers, and doctors. They have undergone a strict selection and long training to become the first people to conquer another planet. And these guys don't have a return ticket. They'll have to stay on Mars for 2 years. The astronauts live right in their spaceships and try to get used to the unusual conditions on Mars. The temperature here is about minus 80 degrees Fahrenheit. Also, the gravity on Mars is 2.5 times weaker than on our home planet. That means a person here can jump twice as high and lift heavier objects. But the muscles in human bodies have a hard time getting used to such a difference, so astronauts can't work full-time. The first thing they do is unload cargo ships and deploy life support systems. Some people are experimenting with turning Martian soil into material for 3D printers. Others are setting up greenhouses and cultivating soil to grow plants. The human waste recycling system the robots brought here is used to make fertilizer for plants. 2 more years and 2 months have passed. We see a launch of a spaceship, not from Earth, but from Mars. The 30 astronauts have completed their mission and are on their way home. It's easier for spaceships to take off from Mars because the gravitational force here is less powerful. At the same time, ships are launched from Earth. They'll bring nearly 100 new inhabitants and even more cargo to Mars. When this space fleet arrives at the red planet, the astronauts can taste the first food grown here. 3D printers begin building homes on Mars. They print outer shells from Martian soil and plant waste. These shells will protect the dwellings from solar radiation and strong winds. And inside the shells, people will build permanent houses. They're inflatable and are equipped with modules brought directly from the spaceships. These houses have living bays, research bays, and communication centers. The construction goes on for 2 more years until the next flight window opens again. Some astronauts leave Mars, but more and more people come here with every new mission. They no longer live in spaceships. There are comfortable underground houses and 3D printed shelters. Most of the food is already produced on Mars. A new generation of robots works together with farmers. Other robots help to build even more houses to accommodate the ever-increasing human population. 2 more years have passed. Various space agencies launched their missions to Mars. There are more people, more scientific equipment, and even tanks with fish. In 2035, Mars and Earth are at a record short distance, so people send a huge fleet of ships with astronauts and construction materials. By this time, the human colony looks like a small city with many interconnected domes. Its inhabitants have already begun building an underground network of tunnels to move between houses, laboratories, and factories. They've also built the first hospital. 2 years later, the population of Mars reaches the 1,500 mark. Almost all of these people will become permanent residents of the planet. 4 years and 2 more launch windows later, the first restaurant opens its doors. Also, the construction of a nuclear power plant begins. Once it's finished, the Martians will no longer need constant supplies from Earth. From above, the colony looks like a small town. There's a farming section where food is grown, a living section, and a factory district. And with each new mission, people bring more and more solar panels. Now their total area equals dozens of soccer fields. All this allows the astronauts to feel at home. They also don't have to wait for food supplies from Earth. 20 years of the human colony on Mars. Its population is now about 30,000 people. Workers begin to bring their families to Mars. The first schools are built here. 30 years. The population is already over 100,000 people. The colony's infrastructure allows it to be completely self-sufficient. People produce enough food, get enough fuel and oxygen. Around this time, the first plants start growing in Martian soil. There's more and more oxygen in the planet's atmosphere. The trees planted in greenhouses contributed to this. The greenhouse effect from all the human activity helps warm up the surface of Mars, if only a bit. People still have to wear spacesuits when they go outside. It will take many more years until people will be able to breathe on Mars like they do on Earth. Gradually, rivers and lakes will appear. Green plants will cover most of the land. And then the inhabitants of Mars will be able to go outside without an oxygen helmet and call the red planet, now green, their home.
You take a rocket to the moon. It lands. You put on your work uniform and go to work your shift at a local factory that extracts water from beneath the surface of the moon. There's also fuel plants here. Dozens of people and rovers are roaming the expanse of Earth's natural satellite. When your shift ends, you board the rocket again. It takes you back home, just like a regular bus. That's exactly what NASA is planning to do. In the first stage of this project is the Prime 1 mission. Prime stands for Polar Resources Ice Mining Experiment. The mission starts in 2022. Let's follow it step by step. A booster rocket and second stage are assembled on the launch pad. Ignition. The rocket's engines begin to burn fuel, and we go up. Soon, the rocket reaches a speed of about 24,000 miles per hour. At that speed, you could travel the distance from New York to London in just 8 minutes. Once the booster uses up all its fuel, it undocks and makes a soft landing on Earth. The second stage with the payload capsule fires its engines a couple of seconds after the first stage undocks, so the rocket continues moving up. Once it reaches orbit, the payload capsule opens. It releases the lunar lander Nova-C. It's a cylindrical spacecraft, as long as a sedan and slightly wider than the height of the average person. It starts its engine and begins its journey. First, the lander makes a circle around Earth. This is a gravitational maneuver that helps it to gain speed without wasting too much fuel. Because the lunar lander is still in orbit, Earth's gravity affects it. The spacecraft looks as if it's falling, but not to the surface of our planet, along its orbital trajectory. After one lap around Earth, the lander adjusts its trajectory and heads for the moon. The distance it needs to cover is 238,600 miles. That's like 9.5 trips around Earth, or 93 trips across the United States from coast to coast. Modern spacecraft can cover this distance in as little as 9 hours. That's a bit more than a journey from New York to Los Angeles by plane. At the same time, it took the first astronauts about 72 hours to get to the moon. Soon, Nova C is near its destination. It makes another circle around the moon while it descends. Scientists have already chosen the perfect plane for it to land. There are several requirements. First of all, there should be signs that there might be ice under the surface in this location. Second, the lunar module should be able to maintain radio communication with Earth. And this is impossible if the lander is on the far side of the moon. When the first astronauts flew around Earth's natural satellite, contact with them was lost for a few minutes. The connection only resumed when their spacecraft came out of the lunar shadow. And the last requirement for the landing area is sunlight. The lander has solar panels to power its scientific equipment, onboard computers, and communication modules, so it needs direct sunlight. The lander is getting closer to the surface of the moon. The spacecraft is slowing down as it approaches the landing site. Now, it's almost hovering in midair. A few more seconds, and touchdown! The spacecraft makes a soft landing. It's time to drill through the surface. For this, the lander has a device called the regolith, an ice drill for exploring new terrain. To put it simply, it's a large, 3-foot-long drill. That's almost as long as a grown-up person's leg. Once the right spot is chosen, the device gets lowered into the lunar soil. Drilling will have several stages. Lander will have to lift the drill several times to get the soil out of the drill hole. Otherwise, it may damage the drill bit. Next, the lander will have to analyze the soil composition. To do this, it carries a mass spectrometer, observing lunar operations. Shortly, M-SOLO. Its work is based on a simple principle. It ionizes or charges particles of soil, making them move. Then it creates a strong magnetic field, which affects the charged particles, making them change their trajectory. Different substances, their molecules, and atoms move differently in the magnetic field. So, by analyzing the changes in their trajectories, we can identify the mass and charge of each particle. All we need to do next is look at Mendeleev's periodic table and see which atoms we can find in the samples. Scientists hope to find H2O, water. The south pole of the moon is an ideal place to keep ice within reach of our drill. The equator would be a great place to maintain radio contact and power the solar panels of the lander, but this area is likely to be too hot to have any ice. The lander will also carry a lunar hopper. This thing will be used to explore the surface of the moon. It will carry a load of about 2 pounds. Scientists will also test 4G communication technology. The lander should have some special modules for this. If the test is successful, people might be able to use cellular coverage for communication on the moon, like we do on Earth. But the main goal of the mission is to prove that the resources found on the moon can be used in the future. As early as 2023, NASA plans to send an autonomous rover called Viper, which stands for the Volatiles Investigating Polar Exploration Rover, to the moon. It'll land at the moon's south pole for the same reasons: the connection with Earth and sunlight. The rover itself will be about the size of a golf cart. It'll carry a drill and soil analyzer. Scientists have already laid out a route for the rover. It's about 10 to 15 miles long. It'll take Viper 100 days to travel along that route. It'll drill the soil in search of lunar ice and mark its findings on the map. It will be necessary to prepare for astronauts' arrival to the moon. It'll also help to provide them with valuable resources, like water. Later in the 20s, NASA will launch the Artemis mission. For this purpose, scientists have been constructing the Orion spacecraft for decades. It can carry 6 astronauts. The launch vehicle that will take Orion into orbit is called the Space Launch System. When ready, it'll be the most powerful rocket in human history. The first flight will be uncrewed. It's scheduled for 2022. Like the lunar lander, the spaceship will ascend into orbit, make one revolution around our planet, and go to the moon. Once it reaches the satellite, it'll stay in orbit for 6 days and then return to Earth. It'll spend a total of 25 days in outer space. The second mission is planned for September 2023. This time, we'll send 4 astronauts to the moon. They will fly around Earth's natural satellite and return without landing on the lunar surface. This will be the first crewed mission to the moon since 1972. The third mission, Artemis 3, is scheduled for the 55th anniversary of the first lunar landing in 2024. 4 astronauts will travel to the moon's orbit. Once there, 2 of them will move to the Starship HLS. This is a new lunar lander designed by SpaceX. Then they will make a soft landing on the moon's surface. The astronauts will spend several days there. Then the lander will fly back into orbit, dock with Orion, and return to Earth. There's also plans to build a space station in lunar orbit, the Lunar Orbitable Platform Gateway. It'll be almost like the International Space Station. It'll be assembled from a lot of modules, just like the ISS. There will be a power and propulsion element. This is going to be the first module equipped with engines for maneuvering and propulsion. There will also be solar panels that will power the station. One more module will serve several purposes, including communication and refueling. Then, there will be several living modules. They will be able to host several astronauts for a period of up to 90 days. That's where they will eat, sleep, train, and conduct scientific experiments. The station will be equipped with a robotic arm. It'll help spacecraft dock with the station, as well as install additional scientific equipment outside the station. There will be an airlock module. Incoming spacecraft will be able to dock with the station there. It'll be like a parking lot for dropping off and picking up passengers. Astronauts will be able to use it as a door to outer space. There will be a sample return vehicle, a small spacecraft that will deliver samples of lunar soil to the station. It'll be fully robotic. The Gateway will be much smaller than the ISS. For comparison, the near-Earth station now consists of 11 modules, and its total cost is about $150 billion. In the future, we'll use this station as a launch pad to send spaceships to other planets, like Mars or into deep space. Rockets launched from the ISS will need much less fuel because they won't have to fight Earth's gravity. But the astronauts on the Gateway will be in more danger than on the ISS because of radiation. Earth's magnetic field acts as a shield that disperses the sun's harmful rays. And astronauts staying there don't get much more radiation than the passengers of a commercial airplane on Earth. The moon is too far from our planet's magnetic field, so all the modules of the Gateway station will have to be additionally protected from solar radiation.